In 1906, at the Mariinsky Palace in St. Petersburg, a prototype of a new piece of technology was demonstrated to Emperor Nicholas II. It was an armored vehicle weighing about 3 tons, equipped with machine guns and armor designed to withstand rifle fire. After inspecting the design and the rotating turret, the monarch assessed the development's potential positively, noting that mobile fortifications like this could play a role in future military actions. Yet, despite this preliminary approval, a few months later, a special commission issued a negative verdict. The main reasons for the rejection were insufficient armor, poor maneuverability, and unsatisfactory firing accuracy. The project was not adopted for service. This decision prevented the country from becoming a pioneer in the creation of armored forces, a failure that would have consequences 8 years later with the start of a massive European conflict. The initiative to create this machine had emerged in 1904. Its creator was Prince Mikhail Nakashidze, a staff captain in the Siberian Cossack host. The officer had previously published a work on the strategic importance of the automobile and proposed a concept for converting transport vehicles for combat missions. An order was placed with the French firm Charon, which had experience in this field. In the spring of 1906, the finished model was delivered to Russia. The vehicle could reach speeds of up to 60 kilometers per hour, which was a high figure for that period. Its weaponry consisted of 2 Maxim machine guns. One was mounted in the turret and the second was located inside the hull. The War Department, however, stuck to conservative views, placing their bets on cavalry and infantry, and failed to see the prospects for armored technology. In August 1914, with the outbreak of hostilities in Europe, German troops employed a vast arsenal, including armored cars, the very type of weaponry the Russian command had turned down 8 years prior. German armored cars proved highly effective against infantry and during operations in the rear. Realizing the urgent need for similar equipment, the Russian military moved quickly to outfit the army with armored cars. An order was placed at the Russo-Balt factory in Riga, which had previously specialized in producing passenger cars. Engineers used the Model C truck chassis as a base, working rapidly to convert them. They plated the body with armor, installed 3 Maxim machine guns, and reinforced the suspension. The result was a vehicle 4.5 meters long, 2 meters wide, and weighing 4 tons. A 40-horsepower engine allowed it to reach speeds of 20 kilometers per hour with a range of 200 kilometers. A crew of 5 could fire the 7.62 2mm weapons in practically any direction. In the fall of 1914, a batch of 8 Type C armored cars was sent to the front. The troops welcomed the new equipment as an effective way to counter the enemy. Field use confirmed the effectiveness of the vehicles, but it also revealed a shortage of production capacity. The factory could only turn out a few units a month, which didn't meet the high demands of the front. To solve the problem, a special commission was sent to Great Britain. An agreement was reached to build 48 Austin armored cars, armed with 2 machine guns in rotating turrets. This layout allowed them to fire in different directions at the same time, boosting combat capabilities. However, the armor on these vehicles was 4 millimeters thick, which Russian specialists considered insufficient for protection against rifle fire. Upon arrival, the vehicles were modernized by installing 7 millimeter armor plates. Cooperation with foreign manufacturers didn't end there. The Russian Military Commission organized large-scale purchases of armored vehicles abroad, signing contracts with manufacturers from the United States, Italy, and France. However, the arriving vehicles didn't fully meet the specific demands of combat on the Eastern Front. Among the noted flaws were thin armor, insufficient weaponry, and design defects. The French Renault models were delivered with vertical armor that was vulnerable to small arms fire. The American units had issues with engine reliability, and the Italian machinery handled the local road conditions poorly. The Engineering Corps began an extensive modernization of the imported chassis. French vehicles were fitted with sloped armor plates, which increased the chance of a ricochet and improved overall protection. British light armored cars, initially equipped only with machine guns, were retrofitted with 37 millimeter cannons to deal with fortifications. The chassis of the American Garford truck underwent a significant redesign. They mounted a 76 millimeter field gun on it, classifying the vehicle as a heavy cannon armored car. A key design feature was the transmission, which allowed the vehicle to drive in reverse at the same speed as it did forward. This made it possible to deliver a strike and quickly leave the position without having to turn around. High mobility allowed the armored vehicles to quickly take cover after an engagement, escaping before the enemy could react. The Army adopted the practice of giving individual names to the armored cars, much like warships. They used names designed to have a psychological impact, like Immortal or Dragon. Crews painted mottos and emblems on the hulls. A strong bond formed between the men and their machines, fostering unit cohesion. In the summer of 1915, the Belgian Armored Division arrived with a force of 350 men. Soldiers from that nation continued to fight as part of the Allied forces. Nicholas II reviewed the formation at Paterhof. The procedure included inspecting the vehicles and speaking with the officers. The unit's equipment was impressive: 6 staff cars, 20 supply trucks, 18 dispatch motorcycles, and 130 bicycles. The main strike group consisted of 13 armored cars of various types, including models armed with cannons and machine guns. A month later, Belgian units joined the action on this sector of the front, proving their tactical worth. But the nature of the fighting demanded new technical solutions. Using the Jeffrey chassis, Staff Captain Poplavko developed a specialized engineering vehicle. Devices mounted on the front of the hull were designed to cut through barbed wire and clear paths for the infantry. The armored car would push out in the lead, taking heavy fire. Its armor protected it from bullets, while the machinery cleared the obstacles, allowing soldiers to follow behind with far fewer casualties. Another officer, Staff Captain Nekrasov, proposed a concept for armored cars with combined mobility. By using swappable wheels, the vehicles could be quickly converted to run on railway tracks. This modification meant they could travel on both roads and rails, reaching high speeds and gaining access to rear areas. At the same time, the nature of warfare was changing with the arrival of aviation. Beyond just reconnaissance flights, planes began to be used for bombing and strafing ground targets. In response to this aerial threat, the armored cars were upgraded. Machine gun mounts were adapted for anti-aircraft fire, allowing them to aim at a much steeper angle. Crews were trained to shoot at moving aircraft, learning how to lead their targets. The downing of the first planes confirmed the potential for using armor in air defense. However, operational use also revealed significant technical flaws. The armor often proved vulnerable to heavy machine guns and light artillery. The chassis, based on commercial truck components, suffered under the extreme weight of the armor and weapons. This led to frequent breakdowns of the springs, frames, and transmission. Pneumatic tires were vulnerable to bullets and shrapnel, causing vehicles to break down right in the middle of combat. Off-road performance was also unsatisfactory. Heavy armored cars bogged down in the soil, unable to cross ditches and craters, often getting stuck on washed-out roads. Wheeled vehicles proved ineffective against trenches and engineering barriers. The military departments of all sides involved in the conflict began looking for technical solutions. Priority was given to reinforcing the armor. The thickness of the steel plating increased from 7 millimeters to 12 and then to 15. The increase in vehicle mass was compensated by greater survivability. The German 1917 model anti-tank rifles could no longer penetrate the updated protection. The second stage was modernizing the running gear. Pneumatic tires were replaced with solid rubber ones, and later by metal discs with pads, which eliminated the risk of a complete stop due to punctures. The machines retained the ability to keep moving and fight even with damaged wheels, despite reduced speed and poor handling. At the same time, work was being done to systematically increase firepower. Since machine guns were no longer enough, artillery systems of various types began to be installed on armored cars. Light 37mm cannons were replaced by 45mm ones, and then 76mm field guns came into use. In some cases, mortars and 122mm howitzers were mounted on truck chassis. This resulted in mobile artillery units of high destructive power capable of destroying field fortifications and dugouts. The significant recoil during firing required the use of special supports and spades to stabilize the platform. Similar engineering solutions were also being developed and applied by designers in Russia. At the Putilov plant in Petrograd, a series of experimental vehicles with heavy armament was developed. One modification featured a mount consisting of 4 Maxim machine guns. This allowed for simultaneous high-density fire, effectively suppressing enemy troops. Another design variant included a flamethrower with a range of up to 30 meters, intended to take out fortified positions. The use of weapons like these had a major psychological impact on the opposing side. At the same time, work was being done to optimize the hull geometry. They introduced sloped armor on the front and sides, used streamlined turrets, and added protection for observation slits. These technical solutions were aimed at increasing the survivability of both the vehicle and the crew. They also installed extra fuel tanks, radios for communication, and smoke screen systems. The armored car design evolved into a complex combat system, but its effectiveness was limited by the conditions of positional warfare. Layered defenses, including multiple trenches, barbed wire, ditches, and minefields, created insurmountable obstacles for wheeled vehicles. The machinery simply didn't have the off-road capability to cross such fortifications. When approaching the front line, the vehicles often lost mobility in front of obstacles, becoming stationary targets for artillery. This led to their destruction and the death of their crews before active combat even began. Combat analysis showed the need for a fundamentally different type of machine capable of overcoming these engineering barriers. This helped form the concept of tracked vehicles, which were subsequently used in combat during that period. For Russia, the war ended very differently than it began. The events of February 1917 brought down the monarchy. Emperor Nicholas II, who had once personally inspected the first armored vehicles, abdicated the throne. The provisional government formed in Petrograd intended to keep fighting, but anti-war sentiment was growing among the troops. Desertion and attacks on officers became common. Military units were falling apart, and the armored divisions were splintering too. Some crews stayed loyal to their oath, while others embraced revolutionary ideas. October 1917 brought a total regime change. Power in Petrograd passed to the Bolsheviks, led by Lenin. A new era of history began with a blank shot fired by the cruiser Aurora at the Winter Palace. Armored cars played a crucial role in these events, securing control of the capital's streets. Their machine guns were used to suppress resistance from cadets and Cossack units. Unable to mount an effective defense, the provisional government collapsed. Armored units either defected to the rebels or remained neutral. The Civil War followed, a massive internal conflict. Society was fractured. Former comrades and family members often found themselves on opposite sides of the barricades. The struggle unfolded between the Reds and the Whites, the Bolsheviks against the supporters of the old order. Fighting raged across a vast territory, from the Baltic to the Pacific, from Arkhangelsk to Crimea. In this environment, armored cars became a vital tool for all sides. Possessing armor meant controlling roads, cities, and rail hubs, a key factor in holding power in major centers. The Bolsheviks inherited a significant portion of the former Imperial Army's armored forces. They secured the arsenals and depots in Petrograd and Moscow, housing dozens of vehicles, and were joined by loyal crews. However, the technical state of the fleet after years of war was considered critical. Amidst the economic crisis, with factories at a standstill and funding dried up, producing new equipment was impossible. There was also an acute shortage of spare parts and fuel. The only solution was to repair the old armored cars, often by cannibalizing several damaged vehicles to build a single working one. Mechanics performed complex restoration work right in the field, taking on machines with serious damage to the hull and chassis. The repair process involved patching bullet holes, straightening bent frames, and rebuilding engines by replacing worn-out components with makeshift parts. Transmissions were assembled from parts of different vehicles, while wheels were scavenged from trucks or civilian transport. The priority was simply to ensure they could move and fire. Some armored cars were restored multiple times, returning to action again and again. The nature of the Civil War differed significantly from the positional stalemates of World War I. Instead of solid front lines and trenches, armies conducted deep raids, seizing territories and cities through maneuver warfare. Cavalry played a significant role on all sides of the conflict, including the Red, White, and insurgent forces. It was precisely in the conditions of this mobile warfare that armored cars were able to demonstrate their tactical effectiveness. Armored vehicles were used as the primary means of reinforcement during cavalry operations, supporting mounted attacks with machine gun and artillery fire. Standard tactics called for deploying several armored cars at the vanguard of the regiment. Return fire from enemy small arms generally did no harm to the protected vehicles. Once they closed to within direct fire range, the crews would suppress fortified positions using machine guns and fragmentation shells. With the defenders pinned down by heavy fire, the cavalry charge would begin. The horsemen took advantage of the enemy's confusion to break through defensive lines. If the opponents retreated, the armored cars switched to pursuit, firing continuously. Engagements like these inflicted significant damage on enemy units and allowed for the capture of supply trains and large numbers of prisoners. Military leadership quickly realized the tactical value of these vehicles, which drove the demand for a larger fleet. Specialized armored detachments were formed and attached to cavalry divisions and corps. The size of these units varied from 3 to 10 vehicles with different roles. Light cars were used for reconnaissance and security, heavy cannon-armed vehicles for storming fortifications, and medium ones for general support. Crews were staffed with trained personnel, often qualified factory workers who possessed the skills to make repairs in the field. The Austin armored car remained the most common type. Built on a British chassis and modified by engineers, the design was considered quite reliable. Its 2 turrets allowed for 360-degree fire, while the reinforced armor could withstand bullet hits. Despite the maintenance required for the running gear, the vehicle was valued by technical crews for its ease of operation and repairability. Throughout the conflict, older models also saw action, such as the Russo-Balt cars from the First World War. Over time, their design went through significant changes. More powerful engines were installed, armor was reinforced, and weaponry was upgraded, sometimes even swapping out machine guns for light cannons. French vehicles like Renaults and Peugeots were also used, but due to a lack of factory spare parts, mechanics often had to repair them and machine components by hand. Armored vehicles were actively used in Soviet propaganda, becoming a visual symbol of the new power right alongside political imagery. Images of armored cars were mass-produced on posters and appeared in literature and films, embodying military potential. The successful actions of armored squads were regularly covered in the press and on the radio, while distinguished crews received state awards and media attention. The White Movement also possessed armored units, formed using equipment from the former Imperial Army or captured vehicles. Denikin's units in the south, Kolchak's troops in Siberia, and Yudench's forces in the northwest all had their own armored divisions. The officers, many of whom had fought in World War I, were familiar with the tactics of mechanized warfare. The combat effectiveness of these units was high, setting the stage for direct clashes with enemy armor. Such head-to-head battles were rare, but intense. The tactics usually involved vehicles closing in on each other across open terrain. The outcome generally depended on crew coordination, aiming speed, and the accuracy of the first shot. A direct hit often led to critical damage, fire, ammunition detonation, and the loss of the crew. Pushing forward, the armored units rolled past destroyed vehicles. The crews remained in a state of constant readiness for clashes with infantry, cavalry, and artillery. By the end of the Civil War, when the Red Army had gained a strategic advantage, its ranks included 52 armored detachments. The fleet relied primarily on modified Austins, which, despite repeated repairs, remained combat-ready. Every vehicle had covered vast distances and seen action in numerous battles. The crews changed frequently due to combat losses. Many vehicles were given their own names, but intense use had led to critical wear on the equipment. Engines were in need of major overhauls, the running gear was failing, and the armor bore the marks of numerous hits. There was an acute shortage of spare parts, fuel, and lubricants. The state's economy and infrastructure were in ruins after 7 years of continuous military conflict. Industrial plants stood idle due to a lack of raw materials and power, while skilled personnel had been lost, either killed at the front or driven out to the countryside. Work at design bureaus had practically ground to a halt, and technical documentation was lost. Under the circumstances, the design and production of new models of armored vehicles seemed impossible. The Red Army continued to operate its existing fleet even though the hardware was worn down to the limit. Mechanics kept the machines running in the face of severe shortages. Parts were often manufactured on obsolete equipment in poor lighting. Materials were recycled to rebuild wheels, while armored hulls were repaired using parts stripped from damaged vehicles. Often, a single combat-ready unit was cobbled together from several broken-down machines. Engines were fitted with spare parts from civilian cars, tractors, and riverboats. These hybrid designs could still move and fire their weapons, which was the main requirement given the situation. By 1921, some Austin armored cars had gone through so many major overhauls that they had practically lost their original configuration. The vehicles were a mix of engines and transmissions from various foreign makers, chassis parts from captured trucks, and locally reinforced armor. They kept running this modified equipment simply because there were no alternatives. Command realized the need for a complete re-equipping of the armored forces, but the economic situation limited their access to resources. Russo-Balt vehicles were gradually phased out due to metal fatigue in their frames and critical engine failures that couldn't be fixed without spare parts. Equipment that had been in use since 1914 was decommissioned as its lifespan ran out. Some of the scrap vehicles were mounted on pedestals at military bases as monuments, symbolizing the end of an era. The armed forces were in need of a new generation of armored cars, vehicles with modern specs, powerful engines, reliable suspensions, and reinforced protection. Even though design bureaus were already working on promising new projects, organizing serial production remained a tough challenge because the necessary industrial base was missing. Launching the assembly lines required machine tools, raw materials, trained personnel, and time. Under these conditions, armored units continued to operate their existing fleet, forced to carry out repairs after every single engagement. The era of the first generation of armored cars was drawing to a close, making way for machinery designed during the Soviet period. The Russo-Balt armored cars, having been in service for a long time, had finally exhausted their lifespan. These vehicles were used in 3 separate conflicts and operated through the changing of several political regimes. The transformation of the armed forces from the Imperial Army to the Red Army, as well as the events from World War I to the Civil War, all happened with the active participation of this hardware. The practical experience gained from these machines confirmed the effectiveness of armored forces and laid the groundwork for the future development of tanks and armored personnel carriers as distinct classes of weaponry.